All right, so welcome everyone. Thank you for joining us today for our online event, What's New in Data and AI with Google Cloud. I'm Lisbeth, I'm CMO at Devoteam G Cloud, and I'm hosting you today. What's on our agenda? First, we'll talk about what's new in AI, and then we will talk about what's new in data analytics. And to finish off, we have a Q&A as well, in which you can ask your questions live to our experts. And our experts are your speakers actually for today are Tristan and Matthias. I'm very happy to introduce them to you because they will be bringing the content to you today and will be answering all your questions at the end of the call. So you can always leave your questions in the chat already, or you can ask them at the end of the presentation today. So we have for today Tristan van Tielen, who is Google Cloud Machine Learning Tribe Lead at Devoteam. And we have Matthias Manninger, who's EMEA Google Cloud Data Pre-Sales Lead and also Head of Data and AI in Sweden at Devoteam. So welcome to both of you. And I will, without further ado, leave the floor to Tristan to talk about all the novelties that we have in AI within Google Cloud. So Tristan, the floor is yours.
Yeah, I'm not able to present, I think, or
that's right now.
All right, so I'll start already. So as you know, a lot of exciting things have been added to GCP in the past couple months, right? Especially in the area of AI and generative AI more specifically. As you all know, there is a big race going on to have the fastest, cheapest, most accurate model in terms of processing text. And GCP has actually come out with a very, very strong offering in the last couple of months. I think we've seen a big catch-up movement with the release of Gemini 1.5, both Pro and Flash. So for those who are not aware, Gemini actually provides two different models. Pro model is meant for difficult tasks, big context window, and most accurate retrieval, but it's a bit slower compared to Gemini Flash. So Gemini Flash has the same large context window, has still great quality, but it's more aimed towards chat use cases. Right? And so both of these are GA. New versions are getting released with new updates. So for example, we saw the context window already grow from 1 million to 2 million. So they keep getting new versions, and both of those are actually now, I would say, best in class in terms of the performance that they offer for the use cases that they're applied. In case you didn't see it, Gemini Flash also got very favorable pricing update recently, dropping about 75% in price. So for those looking at doing those chat use cases that maybe before were a bit more challenging to make profitable, this is definitely useful for you. And so the goal for today is also to have an interactive discussion. If you have any questions, feel free to hop in, ask them either in the chat or just raise your hand to ask a question. And we're happy to discuss, of course.
And I will demonstrate how that would work. So I actually have a question. What do you recommend, Tristan? Would you recommend us trying out with Gemini Flash, and then if we see that it's not enough, then go to Gemini Pro, or try with Gemini Pro first, 1.5 Pro, and then scale down to Flash? So how do I decide which one to use for my use case?
Yeah, I see my connection is dropping a little bit, but normally the way we do it is we first try out Flash because it's fast for iteration to get the prompt down to where we want it to be. And then we check, is the upgrade to Pro worth it, yes or no? But you can get very far already with Flash. Only if you see that something isn't working, you can actually say, okay, let's try Pro first. But normally we try Flash first because it's very cost effective. And I would like to avoid sticking with Pro if it's not necessary. Okay. Cool. I'll move on. We'll stick on the area of GenAI for a bit. So if you have questions, definitely feel free to hop in. Another model that has been introduced in the family of GenAI is the new Imagen 3 model. So Imagen is Google's image generation model. In this case, Imagen 3 drastically improved quality. And Google also went the same route where they provide one most accurate model and one faster model, especially towards chat use cases. That's extremely valuable. Having that interaction with a customer, we all know how frustrating it is to have that donut turning there waiting to get an answer. It's really where Imagen 3 fast comes into play. Very important here is we all know that there is a big concern with regards to maybe images being faked, images not coming from artists being used for specific things. All these Imagen 3 images automatically have a digital watermark built in. So that means that you know that these are AI generated and that can be verified by the tool that Google provides. You can also reserve provision throughput. That's something I'll talk a little bit later on today. But Google is very confident in stating that this is an image generation model that will not output any, let's say, offensive things. That's something that they also very strongly focus on. Moving forward, just to give a couple of examples, you can see here the improvement from Imagen 2 to Imagen 3. So we all know that Imagen 2 and most image generations models actually struggle generating people. Especially the creepy hands that you see at the top left is a classic symptom of AI-generated images. You can see now with Imagen 3 that actually got a lot better, right? And the customer like Shutterstock, they actually realize that as well, and so they now have a lot more confidence in putting this somewhere that's user-facing, because the quality has improved drastically. Another important cost-cutting tool is context caching. Context caching is something that you can already use today, and is especially interesting when you look at that 2 million context window that we discussed, right? Of course, it's not cost effective if every time you get billed for 2 million tokens. That's not a good way to implement your application. And so what Google is offering here is something called context caching, where you can actually cache fixed context so that you don't get billed for that every time. So how can you imagine that working? Let's say you have a huge data set of research papers, for example, and you want end users to be able to answer questions about those. Then what you can do is you can actually cache those research papers in the context cache. So you process them once, but you can generate a lot of responses from the same cached context. So that drastically saves you time and money. Do note that this is only available as of when your context window is big enough. So you cannot do this with a context that's only like 30 sentences. That's not cost effective. So this is really aimed at big catalogs of information. Next to that, I will say, we all know RAG, or for those who don't know, that's retrieval augmented generation, where we basically get a question, we look for relevant information in the data set, and we use that to feed it to the LLM to answer a question. One thing that Gemini models are actually extremely good at is finding the needle in a haystack. So let's say you have a large body of text and you want to find one specific answer. Gemini is really good at that. It used to be a bit cost prohibitive because of the fact that you always needed to process the entire document. This is exactly what context caching also helps with. So this really allows you to leverage that big strength of having a Gemini model. Another example could be, let's say you load in a large movie, put that in the cache, and ask questions about it. Cool. Moving onward, as I promised, I will go through provision throughput. So for those who have worked with Gemini models, especially moving closer to the production sphere, you might have noticed that it's a bit hard to know exactly how much you're going to spend, right? You're going to get a lot of requests from a lot of users that will vary dynamically, and you want to avoid spikes in billing because of the amount of tokens you're processing, spikes in latency because you don't have that assured availability. Well, Google has actually come out with a service called Provision Throughput, where you can actually reserve a specific capacity and know kind of what the cost is associated with that. That's something that we also saw them doing with products like BigQuery, for example. And that really helps kind of making the cost a bit more predictable, right? So you're basically paying a fixed fee to process a fixed amount of information. Good. If there's any questions, again, feel free to pop them in the chat or raise your hand and speak up. That brings us to another nice feature, Gemma 2. So Gemma 2 is of course not a Google Cloud specific thing, but it is very closely related to Google Cloud. This is Google's newest entry in the open source family, right? There's a lot of open source LLM models. And Gemma, when it came out, was actually a very good open source model. However, yeah, this field evolves very fast. Google has now come out with a Gemma 2 model, which is helpful because it gives you a bit more control in the way it behaves. So as you know, for example, Gemini has very strong responsible AI features, which are great for a lot of different use cases, right? Where you want to make sure that nothing offensive is coming out of your chatbot. However, we see some use cases like very advanced content moderation, where you sometimes actually want to process offensive data. That's an example where you could use Gemma, or maybe data that you do not want to put on Google Cloud, or if you want to have full control over the model you're using and keep that flexibility of moving to another cloud provider, etc. This is where an open source LLM can really be helpful. And so Gemma 2 is now available as a click to deploy model on Google Cloud, which is great because it means that in terms of infrastructure management, you don't need to do a lot. And it's very consistent with the way that Gemini behaves, but it allows you that flexibility of moving around that model if you ever need to, should that be something of interest. There's also larger sizes of models that are a bit more accurate than the original Gemma. Moving on, we come to grounding on Vertex AI. One big challenge with generative AI applications is that they can hallucinate, so basically make up information, right? And the way we have seen that solved the best in the current field is by implementing something that's called RAG. So we basically look for relevant context to answer the question that we want to answer. And we use that context to then provide a grounded answer to that question. So we say, this is the answer to your question, and I think it's because of this information that I found. The easiest example of that is grounding with Google Search, which is something that you can very easily enable, whether you are working with GCP native tools like Agent Builder, or if you're coding yourself using something like LangChain. It's something that's easily available, can be easily embedded. There, you can actually now use Google Search to augment the answers that your chatbot gives. So to give a very simple example, let's say I want my chatbot to be able to say what Devoteam G-Cloud does. Maybe the LLM that I'm using doesn't have that context. But what can I do? I can enable grounding with Google Search. It will basically tell the LLM to do a Google search with a specific search term. We'll get a couple of responses, and we'll be able to say, okay, Devoteam G-Cloud is a premium consulting partner working on Google Cloud, and I think that's because of these links. And these links will then be probably our website, right? The same thing you see happening if you are using Gemini, the consumer version, right? Gemini.google.com. There you also have that feature to validate using Google. That's basically this technology. Now, what's interesting is that Google is intentionally not restricting their options to only that. They actually want you to be able to ground using both third-party data provided by third-party providers. That's something that's not yet there, but they are working on. And grounding on your own data with high fidelity. So this is basically where you say, okay, I'm giving this information to my LLM, and your LLM will then respond, basically saying, this is my answer, and I'm X% confident that it comes from this piece of content. Right? That's a very helpful feature. Why? Because this is not something you can only use internally. This is actually something you can also show to the end users of your application. It helps build user trust, being able to show, hey, I found this piece of information in this piece of text, and this piece of text comes directly from whatever data my engineers provided to me. And so I'm pretty sure that this is actually an accurate response. To show that in action, you can see here basically a prompt where we say, what was Google's revenue in Q1 2024 and what was the year-over-year growth? Let's say we ask that to the LLM and we give it the context of an Alphabet quarterly annual report. It will be able to say, okay, I was able to find this in the text in this specific section, and I'm giving us answer that it was 80.5 billion. If we ask the same question for Q3 2024, that will, of course, not have been in the document at the time this slide was made. So there, it would not be able to find that information. So it would say, okay, I'm not able to find any information about Q3. I can only find Q1. I will say my grounding score is low because I wasn't able to find any relevant information. And so by being able to expose this level of confidence, we're able to give an indication towards our end user how trustworthy a specific answer is. And that's extremely important whenever we're working with end users. We don't want to harm that trust. And we also very explicitly, especially with new regulations in the EU, do not want to give them wrong information. How does Google see this? They basically see it that there should be a sweet spot between looking for grounded answers and having ungrounded answers. How can you imagine this? Of course, if an end user just says hello, there isn't much that your chatbot should look up. It should just say, hi, how are you? Or something like that, right? There's no need to look anything up to answer that question. And so Google is looking into something that they call dynamic retrieval, where, and that's not necessarily a new thing, they want to be able to dynamically choose, do we need to look this up in the knowledge base or the context, yes or no? Do we need to do a Google search, yes or no? That is something you can already code yourself. What is Google doing now? They're actually working on making that something that you will just be able to include in your own application, where the tool itself will choose, do I need to look this up, yes or no? That's something that's not yet there, but that's just to give you a brief insight into the future, what they are working on. I hope that's clear. If it's not, then feel free to ask away. To give an example, here we can see the difference between an ungrounded model and a grounded model. So if we ask who won the Champions League in 2024, the ungrounded Flash model doesn't know that that already happened. Right? And to be honest, I don't follow football, so I hope this is correct. The ungrounded Flash model will just say, okay, that it hasn't happened yet. The grounded Flash model will be able to look that up. We'll be able to say, okay, actually, it did already happen, and this was the specific score. Taylor Swift, yeah, it will say, I don't have access to the information. In the grounded version, it can look it up. In this difference, we can actually see that basically we're scoring the difference to see if we're looking at recent facts, yes or no, or if we're just taking stuff from the memory. We can see that for some questions, the answer doesn't really change. If I'm asking who is Taylor Swift, the ungrounded model already has a lot of context about that from training data that it was trained on. The grounded model will be able to give an information that's maybe a bit more factual, but in the end, will not say that much more. And then write a poem, yeah, of course, there it doesn't really look up for anything. But you need to know that ungrounded prompts, they are a bit faster and cheaper, right? So you want to avoid grounding a model if it's not. That's basically what we're looking at. Right. Another important thing. Okay, I'm sorry, the product name coloring is a bit off. Another important product is Auto SXS. So this is a service that Google offers and has recently been extended. We'll come to that later. That aims at comparing two versions of a GenAI application. So here on the left, we see two models being compared. Actual thing we're doing is comparing two applications that can produce responses. So if we look here, for example, we could be comparing the ungrounded Flash model with the grounded Flash model. And what do we want to do? We want to compare the answers given by both of those and compare them to each other based on a couple of metrics, which could be, is the answer grounded? How comprehensive is the answer? How relevant is it? And how concise is the answer? The nice thing is that this is an automated pipeline that you can just use out of the box on GCP. You just need to fill in these different boxes in terms of which models are competing, and you can get these metrics based on the objectives that you set out. How does that work? There's an autorator, which is basically a third large language model that is judging the responses from both of these. I know that that can seem a little bit not necessarily suspicious, but a little bit unintuitive, because we are using an ML model to judge ML models, and the immediate question is, okay, how accurate is that? Well, the answer is, based on the recent research and state of the art, if your input data set is of an adequate size, that's actually a response that can be trusted. And it works a lot better than what we were doing before, where, for example, people were doing topic modeling to see, is the answer about the same thing as the question? Actually, this is a much better way of doing it. And so what you can do now is you can actually choose yourself what kind of prompt you're using in the autorator. There is something on the Vertex AI website where you can see that, which prompts they suggest, but you can actually edit those. A very important service that I don't know if Matthias, you will talk more about it actually, but AlloyDB has recently really come into the forefront as probably the best vector database on GCP for price per value, right? There is, of course, a native service for this called vector search, which is the most scalable and the fastest. But if we talk cost effectiveness for most use cases, actually, very recently, AlloyDB for Postgres has been coming out on top. Why is that the case? It's because GCP has been investing heavily in making it very performant for doing embedding lookups. Compared to other Postgres databases, so for those not aware, Postgres has an extension called PG Vector, which is very popular to basically do lookups and generate new text based on content that's stored in this database. We actually see that AlloyDB has gotten a huge performance increase compared to those traditional databases. What does that look like? In AlloyDB, you can very easily just add a comparison now to have the distance between an embedding and a vector, and then you can just order by that distance to get the closest item. So in this case, for example, we are looking for the closest products. The nice thing is we can filter on any other attributes in those tables because this still functions as a normal operation database. What can we store there? We can store vector embeddings, which we can generate using SQL. So we can actually use the models from Vertex AI here. We have model endpoint management to work with different models on GCP. In terms of vector search, they worked a lot in improving the speed using the scan algorithm. And it's very optimized for real-world workloads. So that means that they actually have a lot of guidelines also in how you need to tackle the way you set up this vector search for specific use cases. And it integrates nicely with LangChain, which is a very popular open source framework. And it is fully PostgreSQL and PG Vector compatible. So you aren't locked into AlloyDB, but of course, if you were to switch to another Postgres database, do note that you should expect a little bit of performance drop because AlloyDB has been heavily optimized for this specific use case. Good. That brings me to my last slide, where I'm just going to highlight a couple of my other favorite releases that I think are worth mentioning, but didn't merit a dedicated slide. The first one is actually important. Why? Because it's a deprecation notice. Always a bit less positive news, but for those people using AutoML for text classification, entity extraction, and sentiment analysis, be aware that you will no longer be able to train new models. You will have to move to Gemini instead. So Google has a clear migration guide for this on their documentation page. Basically, what you will do is, instead of using AutoML, you will use the Gemini model to perform this task instead, using a very specific prompt that is optimized for that specific task. And I've been testing this myself, and it actually works very, very well, better than the previous model did, but it does require you to change your way of working with it. Another important thing, control generation with a JSON schema. So you were already able to specify that you wanted Gemini to output JSON data. However, now you can actually specify the schema of that data. which is extremely helpful. For example, if you want to extract information from a document, you can actually structure the output. And for every field, you can say, what does this field mean? Where can you find it on the document most of the times? And have Gemini extract a very structured information that can be a bit more complex in terms of structure. Mistral AI, we already had an integration with Anthropic. Now Mistral AI models are also available natively in Vertex AI as a third-party vendor that has official support. So for those people interested in using those models, you can now consume them through GCP, which is interesting in case you have a commit, but also interesting if you just want an easy way to deploy those models. In general, on Vertex AI, you can now copy models cross projects. This might seem simple, but it was not possible before. So if you have a model in model registry, which is a GCP service for keeping track of models and their versions, you can now copy a specific model version to another project. Before this, there were a couple of manual steps involved. This makes that a lot easier. And then an extremely important one for me personally is that Cloud Run with GPU support. It's now available in preview. It does require a whitelist, but this is an extremely promising feature. Why? Because Vertex AI endpoints, as you know, does not scale to 0. Cloud Run does. So especially with expensive resources like a GPU, having a pay-as-you-go service that supports GPU is extremely, extremely, extremely helpful. It allows you to accelerate your workloads in a lot more cost-effective way. So I personally would definitely start looking into this option if you're running ML workloads, because to me, this looks like a very promising and cost-effective way of using that. Do note that it doesn't support all the different GPUs available on GCP right now, but it's a very promising product in my. So that was my last slide. Before I hand it off to Matthias, I don't know if there's any questions on anything that was mentioned in this deck or anything that interests you that you're excited about. Okay. When you mentioned dynamic retrieval, did this AI model also use retrieval augmented generation? So that's a good question. Dynamic retrieval, as I mentioned, isn't really a product that's out yet. But probably what will happen is that there will be an LLM that will decide whether it's necessary to do the RAG part of retrieval augmented generation. So the way you can see that is question gets asked, an evaluator will say, does this question require a lookup in our data? Yes, okay, then we will actually do retrieval augmented generation. No, okay, then we will just immediately respond. And that's going to be faster than always doing the RAG in most cases. And also more cost effective because we're not pulling in a large set of context unnecessarily. But thank you, it was a great question. Any other questions?
Yes, I also have a question. So you mentioned in the beginning something about context caching, and then also later on grounding models. The question is, when would you go either for the context caching, and when would you go for grounding? And do you also see, is there a difference in performance or quality?
Yeah, very good question. So context caching, you still need to process your data at least once. And you need to have a minimum token size, like a minimum amount of tokens. If your context is very consistent, it's basically you need to calculate the price every time for every use case separately, but you need to see how much does it cost to process my entire context once, and then how much would it cost me to set up a RAG system, because you have a cost for a database and everything like that still. For a lot of cases, context caching will actually be very beneficial. So if you have, for example, employee policies that you just want them to be able to answer questions about, that's an option. And that's something we are still experimenting with, you can also still combine RAG with context caching. If you get similar questions, for example, you can imagine I have a user session, and I don't know what he's going to ask a question about. He'll ask a question, and I will look up all the relevant information I have about the topic that he's talking about, use that in my first call to my LLM, and do context caching so that I have all the relevant documentation in the context cache. For the rest of that entire user session, that context can stay cached, saving me money, but also improving the response time. So that's, for me, a very useful way I see it being used. In terms of performance, actually, in most cases, Gemini will be faster with context caching than when you're doing RAG, if you have a good use case for context caching.
And the mechanism that you just explained, that's already feasible or possible, you say, where you combine RAG with context caching.
It is, but you need to implement it yourself a little bit, right? So you need to implement that, for example, in LangChain.
Okay.
That's not pre-built yet.
Okay. Thank you for your answer.
Does context caching create conflict with GDPR? I guess that's GDPR, the General Data Protection Regulation. So, yeah, that's a very good question. In general, you need to see what context you are caching on GCP in general, right? It depends on your internal policies and what kind of information you are processing. However, yeah, I will just quickly make sure that I'm not saying things that are incorrect. You can basically specify at least the time to live of the context cache, and after that, the data is gone there. So that's really a temporary cache that's being used. And you can also choose the location of the context cache. So you actually create a context cache yourself, and you specify it in a specific region. So you can still say, okay, I would like to stay in Europe. Do note that this is still a preview feature, so I don't know exactly which regions are available. But so you can stay in the region that you want to stay in. You can specify a time to live, and Google guarantees that that data isn't then used for any other purposes than only your project and only your specific predictions. But yeah, there are EU regulations. There's also the EU AI Act. So depending on the use case that you're doing and the data that you're processing, you might need to see, is this a valid use to use Gen AI?
All right, let's wrap up the AI part, Tristan, so that Matthias can take over for the data updates.
If you have any other questions, feel free to reach out to me via LinkedIn or wherever you manage to find me, and I'm happy to answer.
Thanks a lot, Tristan, for these highlighted updates. All right, Matthias, floor is yours. What's new in data analytics? That's the question right now for you. You're on mute.
Yes, thank you very much. Thanks, Tristan and Lisbeth. We will start looking at BigQuery, of course, most likely the most used Google Cloud product, at least definitely in data and analytics. So continuing on the generative AI kind of trend, one of the new things in BigQuery is the ability to use Gemini 1.5 Pro and 1.5 Flash. So that means that you can write SQL queries to unleash the power of these models. And I think this is very useful if you already have some data in BigQuery and you want to use generative AI, but you don't want to learn how to code Python and you already know how to use SQL, then this will help you with that. And of course, then you can use all the other BigQuery features in combination with these generative AI models that you already use. So if you use Dataform or DBT or any other orchestration tool, you can use all those and orchestrate generative AI pipelines and workloads. And some of the use cases is, of course, text processing, but you can also use this to get audio transcripts or do document classification with multimodality as well. So you can use this on image data, video, PDF, so many different use cases that you can use this feature for. Next one is also some other things that are released with the 1.5 Pro integration. So grounding with the Google search is also available in BigQuery, and the usage of safety attributes. So if you care about things like specifying your own safety attributes for these models, then now you can do that from SQL as well. You can also now generate video embeddings. So if you have some video data that you store in your BigQuery, then you can create embeddings for those as well. And one more thing that relates to this, not definitely 1.5 Pro, but Gemini 1.0 tuning. So you can do tuning from SQL, from your BigQuery Studio interface for the 1.0 model. Okay, now moving on to non-generative AI related announcements for BigQuery. One thing that I was happy to see is that the number of maximum partitions have increased from 4,000 to 10,000. I don't know if you were aware, but there was a limit of 4,000 partitions. Typically, I see customers partition their tables based on a date column, and then usually you do a day partitioning, so every day is one partition. And with 4,000 maximum partitions per table, this meant that you could store around 11 years worth of data. And now that is increased to around 27 years worth of data. So if you've ever run into this limitation, then you will also be happy to see this increase. The next one is querying AlloyDB from BigQuery. So BigQuery has two parts. One is the storage layer and the other one is the processing layer. And typically you store data in a BigQuery table and process it within BigQuery. But you can use BigQuery to process data stored in other services, for example, Google Cloud Storage or Cloud SQL, and now also AlloyDB. So these federated queries are now also available for AlloyDB. And there are lots of interesting things happening to AlloyDB as well, as Tristan already hinted at the fact that now AlloyDB is kind of our default choice for a production vector database. And there's a lot of support for that from Google, and there are other things happening in AlloyDB. So the fact that you can use BigQuery to process and query your data from AlloyDB with federated queries is a very welcome change in the last few months. Another interesting feature in BigQuery that was released recently, this one is still in preview, is the changes change history function in BigQuery. So you can use the changes function and give it a table and a timestamp, actually two timestamps, start timestamp and end timestamp. And then that will generate a table for you that includes all the changes that happened to that table within that period. So for this feature, of course, you need to enable it for BigQuery to keep all the change history in memory. But after that, you can use this changes function to look at the data that has changed, and this will include inserts and updates and deletes. So this is a great feature to query what's going on within your BigQuery tables. The next one is the continuous real-time analytics in BigQuery. So this feature is in preview, and you have to apply for allow listing to be able to try this out currently. But basically, what this does is that you have some continuously arriving data into a BigQuery table, and you specify a SQL query. And that query will run every time some data is appended to the underlying table. And this can include features like exporting the data into PubSub or Bigtable. So this way you get a serverless data processing, real-time data processing service right within BigQuery. And this is great for reverse ETL use cases or event-driven architectures. And the good part with these features is that since everything we're talking about here is within BigQuery, these play really nicely with each other. So if you think of all the previously mentioned generative AI features, those can be combined with these continuous SQL queries. So you can call text generation or generative AI models from a continuous SQL processing. You can also use this to do real-time anomaly detection, for example, and recommendation algorithms. So the possibilities here are great and almost endless. And now just shotgun method listing a bunch of other smaller BigQuery changes like the slot recommender. So if you're using additions pricing, then you get automatic recommendations on your setup. You can start scheduling notebooks now. So if you've seen, you can create Python notebooks from the BigQuery UI and then store it there. And now you can also schedule these notebooks. If you're using Amazon Redshift but want to migrate to BigQuery, then now there's a tool for the migration assessment that is generally available. You can also export your data to Spanner with the reverse ETL and Bigtable. And then you can also use IAM conditions for your different BigQuery resources. So if you're not familiar with IAM conditions, it is the ability to attach some conditions to an IAM permission. So when you give someone read access or write access, then you can set the expiration time on that. So you can say that, all right, he's only able to read or write to this table for the next 1 week, or only on weekdays, or only during the night. So these kind of IAM conditions. And these also work with tags. So you can specify that, okay, he has access to read things, but only if this tag is present, or only if this tag is not present. Then we have short query optimized mode. This is something that you don't have to do anything to take advantage of. It's just there. So I don't know, you might have noticed it already. This was, I think, middle of August was when it was released. But what it does is that it looks at your query and says, oh, this is a quick one. I don't have to do a lot of processing. I don't have to read a lot of data. This is a short query. And then it does some special magic behind the scenes to optimize the performance for that. So typically, there was a lot of overhead for short queries in BigQuery. It took a long time to run your short queries as well. Yeah, now it's more optimized, so now they are faster. And then anomaly detection with BigQuery ML multivariate time series. So if you have time series data and you want to do anomaly detection with BigQuery ML, and now that feature is also available. All right, next up is the other big piece when it comes to data and storage in Google Cloud, and that's Google Cloud Storage. So one thing that is that didn't work previously was storage cost pricing when it comes to BigQuery. So as I mentioned, you can query data in cloud storage from BigQuery, and due to an issue or a bug, a billing bug, some of these fees were not charged correctly. So from the 1st of November, if you are querying data across regions with the BigQuery and the cloud storage, or you are querying data that is in nearline, codeline, or archival storage, then new charges will appear on your cloud bill. Now, this is something that should have been there in the first place. So it's not something that Google added. It's just that they had some internal bug and haven't been charging you for this. So you got like a free trial of this feature, let's say. But now that free trial is going away. It's just something to be aware of. And if you need help checking whether you're affected or not, then you can reach out and we can help you. All right. Next up is a feature I don't see being used too much, but I think is very cool, is the Fuse library or adapter for Google Cloud Storage. Basically, what it does is that you can mount a cloud storage bucket as a local file system to a virtual machine or Google Cloud Kubernetes engine or on-premises system. And this means that your libraries that expect to read from local file system can interact with cloud storage without any additional coding or modification to the library. And the new features here is that now it supports parallel downloads for files over 1 gigabyte. So if you have really big files, then this becomes faster. And also list caching. So if you're listing your files in a bucket with this Fuse library, then that's going to be faster. Yeah, a really good use case for this Fuse is machine learning, by the way. So if you're doing any machine learning with machine learning libraries in Python, then I suggest you try out this Google Cloud storage adapter. Next is soft deletion. So soft deletion is basically a mechanism in Google Cloud Storage that when you delete something, it's not deleted right away. You can recover it by default for 7 days, and you can modify this to 90 or to 0 or anything in between. And the new announcement here is that you can bulk disable soft delete, so you don't have to one by one disable soft delete on all your buckets. And you can also use tags to set default soft deletion retention duration. So this means that you can say that everything in this specific folder or anything in this specific project needs to have this soft delete retention duration. That's something that was not available before. It was a bit more tedious to set these. And the last cloud storage announcement that I have is the hierarchical namespace. And this is also a pretty interesting one. So if you were not aware, previously your cloud storage didn't have folders. I know you might think that it had, because it had some convenience functions to interpret slashes in the names of objects as a folder structure, but it wasn't stored like that. So in cloud storage, everything was just one blob, and then it had one name, and you could use slashes in that name, but it wasn't actually stored as a folder structure. So this meant there were some limitations to what you could do with your folders. And now with hierarchical namespaces, this changes. So if you set up a bucket with hierarchical namespace, then you actually get folders and objects within folders. And that unlocks a set of features previously unavailable. For example, creating and deleting and getting folders, and also renaming folders without moving all the files that are in the folder, and also listing folders, so without listing all the files. These are all new features in cloud storage. Wild. You can list folders. But this is actually super nice for many use cases, like Hadoop-based processing. So if you use Dataproc or use other methods to run Hadoop and read from cloud storage, then this feature will help speed up your operations. Also, any file-oriented workloads that process a lot of files and really manipulate these files. And then, of course, AI and the machine learning workflows and processing. So libraries like TensorFlow, Pandas, PyTorch, they all rely on this these files and folder structure. Then those become also a bit more efficient with these hierarchical namespaces. And this works with the previously mentioned Fuse connector. So if you mount your cloud storage bucket that is with hierarchical namespaces to do some machine learning with TensorFlow or PyTorch, then you get an even bigger boost in speed, and you can and you still have the convenience of using it as local file system. All right, so those were the big ones, and now we have some other products with more releases. AlloyDB, we mentioned AlloyDB multiple times already. Really good news. There is now a free trial cluster available for AlloyDB. So you can use AlloyDB and try it out for 30 days for free. This comes with a 8 vCPU and with an optional 8 vCPU read pool and automatic storage scaling up to 1 terabyte. So if you're doing some prototyping for your RAG system and you need a vector database and you want to try out our recommended database, then you can do that for free. And you don't have to worry about the end of the 30 days. Your data is kept. You have to pay for the data after the 30 days, but your data will not be automatically deleted, but the instance will be. I think there's like a 15-day grace period or something, but after that, the instance is deleted and it will stop responding. But it's great because now trying out AlloyDB is free of charge. Next up, we have Cloud SQL. A few things that were released in the last couple months here is point-in-time recovery transaction logs stored in cloud storage for SQL Server. The Postgres version 16 is now generally available, and there is also a in-place major version upgrade functionality. So if you're running a previous version and you want to upgrade in place, then you can do that. And there is also now a 5-week maintenance window notification option. So previously it was 1 week and 2 week, and I think it was something differently named, but now they are named 1 week and 2 week, and you also have a 5-week option. So if you want to get notified way in advance before there is going to be some maintenance on your instance, then now you can choose that option. Dataplex catalog can now also search and manage your Cloud SQL resources. So that is great. I will mention Dataplex a bit more later, but Dataplex is your way to democratize data, right? It's democratizing data is not just about giving access, but also how do people discover what data is available and what data they need for their own use case. And Dataplex catalog solves this issue. There is a Cloud SQL Studio. So that's UI, UX improvement. But basically, you can see this small screenshot on the top right. You thought that's BigQuery. No, it's Cloud SQL Studio. I just made it so small that you can't make out the difference. But basically, you get an interface that looks like a little bit like the BigQuery Studio UI, but for Cloud SQL. So you get to see your different schemas and tables and even write queries there, and use similar Gemini features that you have in BigQuery. So you can use Gemini to help you write your SQL queries in Cloud SQL Studio. Migrate to AlloyDB Insight recommendations. Going back to AlloyDB, if you were wondering whether you should migrate your Postgres Cloud SQL instance to AlloyDB or not, now you get Insight recommendations provided by Google and probably Gemini within your Cloud SQL UI. And then a small but impactful change is that now you can use IAM group authentication. which is generally available in Cloud SQL. So you can use groups within your Cloud SQL to manage authentication. Spanner, the other database solution, got some upgrades as well, like Spanner Graph. So you can store your data in Spanner and use purpose-built graph query language to query your data as if it were in a purpose-built graph database. You also get geo-partitioning. So if you have a big Spanner cluster and you want to partition your data and store different rows in different regions to make it closer to users, for example, user-related data, then now you can do that and specify a column that tells Spanner in which region this row should be stored within a table. So your table will be partitioned across the different regions, and this reduces write and read latency. Other use cases are, for example, localized data. So if you're running a company that has a lot of events all over the world, then all the event data can be stored close to the actual event location. And then I already mentioned, but it's worth saying here as well, that you get the reverse ETL feature from BigQuery with continuous or without continuous queries. So you can load your BigQuery data into Spanner directly from BigQuery within SQL. And a little bit about data analytics. So Looker Studio update. This is interesting for those who are running Google Workspace. But now you can add Looker Studio content to your Google Slides. So all the visualizations from a dashboard or just selected visualizations and import components from Looker Studio reports into your Google Slide presentations. And then if you update those visualizations or the underlying data changes, then you get just a button that you can click within Google Slides, and that will update all the content in your slides for that are linked from Looker Studio. So this is great if you have a monthly meeting, a recurring meeting that you present to the finance department, and you want to update the finance numbers. You just create the Looker Studio report, you import that into the slides that you're presenting every month. You can automatically update it. You don't have to do any screenshots or copying or updating. So very, very nice workflow. And my last slide is about Dataplex. So now you get the column level data lineage for BigQuery that's available in preview. Previously, you had the table level data lineage, see how the data flows from different places. But now you get that on a column level as well. And then data insights. So that's a Gemini feature also, that Gemini generates queries based on the metadata of the table. And then it helps you uncover patterns and data quality issues and do all sorts of nice insights into your resources directly from Dataplex. So these were all the data and analytics related updates that I wanted to highlight. And if you have any questions, then we have some time for answering them. Self-delete means extra cost for storing delete. And also that comes with the extra cost. And this is why you might want to disable it in bulk. Let's see. If I understand well, AlloyDB is a fully managed cloud service and has no on-premise version. Or is it possible to have on-premise version? So there is a AlloyDB Omni, which is similar to BigQuery Omni. I don't know if it is possible to run it only on-premise, but definitely like a mixed solution is possible. Yes, there is the documentation, and I'll have to get back to you on that, whether it's possible to run it completely on-premise. Any more questions?
If there are no more,
Reading,
Yeah.
sorry, just browsing through the documentation page. AlloyDB Omni says that it's a downloadable edition of AlloyDB designed to run anywhere in your data center, on your laptop, at the edge, and in any cloud. So I think AlloyDB Omni can run fully on premise, and you can connect to it from the console. Yeah, I think we're 1 minute over time. So thank you for your attention.
And thank you, Matthias, for all these highlights. I think that was very insightful. Well, thank you everyone for attending our event today. We hope to see you at one of our next events. Just so you know, we have this event, What's New in Data and AI with Google Cloud, every 3 months. And we will send you a follow-up, including the slides and recording of today, and an invitation to join the next event. Have a really nice day. Thank you. Bye-bye.
Thank you. Bye.
Thank you.
Thank
Bye.
you. Bye.